Hello, hello! Here we are again. Wednesday evening means coding Tetris and Elm for me. Always looking very much forward to this part of the week. And I was contemplating a bit what to do today. I'm pretty happy with how far we've come, or how far I've come so far. So I think I have a hard and a somewhat easy task. And I think I want some reward for all the hard work of the last weeks, and I'm going to start with the easy part first, which is coming up with a very simple scoring system, just counting lines and displaying them to get some visual feedback and have the whole experience come a bit more together. The somewhat more harder part is to introduce a animation for when lines or rows are collapsed. So I have a bit respect of that task because I can already tell like it's not modeled into the data structure that I've modeled so far, and it's kind of an awkward aspect because it's not really the player, like the logic is not really interested in animation. So I'll see if I want to embark on that endeavor tonight. But as I said, first let's get something quick and easy done here. Let's check the git status, all clean from where I left off last week. So let's start the Vim with my main source file. Another thing that I'd like to do at some point here on the stream is to refactor a bit or just modularize a bit. For if you haven't followed along, this is currently still all in one big Elm file, which is nice for this quick and dirty hacking. But at some point this file that has now nearly 650 lines gets a bit unwieldy to work with. So, and I think it's just a great opportunity also to show the nice module system that Elm has. All right, but a little reward first. Let's do the scoring, and I wonder where to start. I think maybe we start something different and start out with a view this time. I think that's something that we haven't done in the past, or that I haven't done in the past year. So let's find where we assemble the view, and I don't know where to put it. Maybe just above. I think that shouldn't be too hard. So let's see. We have a lot of very special view functions here. Layout, that sounds good. Here's what does the content function do? The content is passed into layout, and my view, the layout is just a wrapper. So I don't know, does it belong to the layout portion, or I mean, we still want to see the score even when the game is over. So I think I will just put another div container here in my layout function, and I want to say delete this string, and the number will be an integer for now, so I already know I have to convert it string, or maybe let's just not namespace it from int and hope I have imported it already. Score. Let's give the layout function another parameter score here. Yeah, and if I am really bad at paying attention to if there's someone in the chat, so I'm trying to look once in a while up to see if somebody has a question. All right, so we pass in the score, and now we need to get the score out of our two distinct game states. I think for the running game, we can just add it to our game details here. And for the game over state, we just add a dedicated field directly to our variant there, and then we just pass it, or maybe we pass it as a first parameter, then it's out of the way for when we construct the rest of the content. So this should work fine, and I'm pretty sure the compiler has something to say about this. Game over variant needs one argument, but I see two, so that's correct. So we go, let's find the definition of the game over variant. Not here, not here, here, and maybe I just feel like I want to have a dedicated type for this. Score. Let's define an alias, which is just aliasing to integer for now. So we have to do the same thing to the game details here. Score. And let's see what the compiler has to complain about next. The game over variant needs two arguments, but I see one instead. So where's this in 471? 471, that's here. And for our subscriptions, we can just ignore this. And now you also see already a bit, I really like this. I went kind of down two different roads here for the game over and the running game state. Like the game over has explicit parameters, and the running game has already only one parameter, which is again like this kind of struct thing that I call game details. And the advantage comes, or the difference becomes clear in those cases where now everywhere where I mention game over or do a pattern matching on game over, I now have to extend the pattern with this score parameter. Whereas with a running game, in most of the places I probably am not interested in the current score, and it just works out. So I don't know, maybe I should have gone with a structured parameter for game over as well, but it's also not such a big deal. Cool. Now this argument is a type record of blah 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 blah. It's probably the init function, I guess. 206, let's see. Yeah, because I'm not initializing the game details struct here completely, so I will just initialize it with a score of 0. Nah, there we go. And now 269, what does it say about 269? I can already see this is a pattern thing again. So now we have, this is actually where we transition from the running game to the game over state. So we kind of want to carry over the state here of the score from the previous game details into our game over state. So I just access this here. Game details get passed in on the top as a parameter, so we can just use the dot notation to access the score here. And it's compiling again. Awesome. So okay, that's great, but obviously like I haven't done any this is fast. Okay, I have to turn down the speed for this. What was it? 100 here. I didn't train enough Tetris to get some lines down at that speed. But we haven't really changed the score I haven't changed the score anywhere yet, so I don't expect the 0. That's like what I wanted to see. I'm seeing it's this the 0 here on the top of the page. But since I never actively added some code that actually changes the score, it will not actually increase. If I manage to clear a row, I can actually show this. So yeah, row vanished, 0 still there. So now we kind of have to identify the portion where the lines removed, or the lines are removed. I think I called it something with erase complete rows. So that's great, but we see also already from how it's called, erase complete rows returns a new board, which is great, but it doesn't tell us how many rows have been removed. So we want to change this. Conveniently, the function definition is just below this, and I will change the return type here to a tuple of board and a number. So let's see. New rows like final header, and the good thing is final header is I went into this into an explanation what this folding here actually does a bit in a few episodes ago. So basically, from our board we are removing all the full rows, and we are collecting, or we are constructing a new set of empty rows that we will put on top of the board to make up for these empty rows or for these full rows that were removed, because otherwise our board would just actually shrink, which is obviously not what we want. So we have the final header, which is the list of empty rows that we use to fill up the board on the top. So that is nice because it makes it really easy for us to calculate how many rows were removed or erased. So we can just say length of this final header. So let's see. And now, of course, we cannot just assign it to this board property of the new game details anymore. We have to deconstruct it. So, or actually, we could also, something else we could do is, instead of returning a board and an integer, return a whole game details state instead. So I think I will do this. We will pass in, what do we have to pass in? Current piece board. Do I pass in complete game details set, or yeah, I think can drop else. I think I will just, yeah, we're operating on the game details here already. So I think I will just make this a function from game details to game details. This way it will make for a nice clean call. Good. Game detail, from game details to game details. Boom, remove this. And deconstruct the board here. Oh no, actually, is it? I think it doesn't work this way because we're not only working. Oh well, I can still call the place piece on board. Yeah, no, I think that should work. So we need the board and we need the current piece. And I will just grab this and put it here as our return value. Boom. And I think I will create a new board expression here where I just assign what we returned before. We can put our score now in directly in this game details value here. Boom. Remove that junk. So we're replacing the board, we're replacing current piece, and as board, well, we still have to incorporate this expression somewhere. So I just park this here, and here we'll call it. We take this new board, new rows. And I think I will just create a board with current piece. where I do the thing that we previously passed in. And current piece is already deconstructed from our parameters, so that's great. And now instead of board rows, we want to have board with current piece rows. So that should be good. Empty row. And now I can just call running game with, whoops, erase complete rows, game details, boom. And 462 cannot find game details. 462. Why not? Because I deconstructed it here as game details. Let's give it a name. 54451. Place piece on board is not what I expect. Current piece, maybe current piece. Okay, I see. Well, I would argue if there's no current piece, then we don't have to place something. So we can just say case current piece of just piece, then place piece on board. And if there is no current piece, then we can just return board. And it's compiling. Yay! So I mean I've rearranged a lot of things, but actually I think I didn't change anything in the user facing behavior, but at least we know now, well, we have knowledge of how many rows we've cleared. Oh no, actually I put in this here, but it's of course not correct. I have to add the previous score as well. Otherwise this will probably be frustrating for players. So let's add the score here to the list of fields we're deconstructing from our input parameters. And now I actually have to clear some rows to see if this works. Okay, maybe I should have put it a bit faster. Yay, 1 point. That's pretty nice. Let's see if it works beyond one line. No. See, I knew it. Yes. So obviously the actual score, I just briefly Googled it. The scoring mechanism for Tetris is actually way more complicated based on how many lines you've already cleared in a row and la 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 la. But I mean, I leave that to you as an exercise when you're following with your own Tetris clone to improve the rules, because it's merely a mathematical puzzle, not really a complicated programming infrastructure problem. Or nothing Elm is better than any other programming language, I would argue. Cool. So that's pretty neat. I think I just actually will make a commit for this. Oh no, I've been contemplating if this was a good strategy, because so far I've always I've always created one commit per episode, and I'm a bit wondering if it would have been nicer if I had broken out, because that's not how I would work. If I would work with actual people on the project together, I would try to create smaller commits, but I think it makes for nicer recaps if somebody just wants to see what changed during a specific episode. So I think I will just not change this, for at least not tonight. So yeah, now up to this, now for this much more dreaded task of trying to animate vanishing rows. And I don't have a good idea. Like designing a data structure for the game itself is much more straightforward than adding something to the data structure that is so much of a display or visualization concern. So if I start thinking about the way I would go about it is to start to think about what I want to see as a user. So I think instead of the line just vanishing, I would like to see it like slowly fade out. So I don't know. So I'm starting to think here from a HTML or DOM or CSS, whatever perspective, like how would I implement such a animation? And I don't know, if I review this, there's probably something that I created in the very first or second episode, is this field view function here that actually renders a rectangle, and this has a color. And currently, like, it's very, very stringy here. Like, I'm just passing in the field color. And field is this algebraic data type that can be either of those. So yeah, in a way, very, very distinct. And we will keep it distinct probably. Or maybe not. So I think what would have to happen is this field has to be more complicated, more complex. Like, we have to have kind of a opacity value attached to this. So maybe the first step to do is go to the definition of field and try to find out. So a field can be either empty or it's a field of field color. So actually, maybe it's more straightforward than I was thinking, and all my fear is uncalled for. So maybe we put maybe let's say we fade out in 10 steps. So let's put an integer here. And let's say if it's we start at 10, or no, let's create a type, opacity, and say for now type alias opacity, because I don't know, maybe 10 is not a good number, and then I want to change it and it's just an int everywhere, and then maybe I want to actually refactor this into something, a float or something between 0 and 1. So, but for now, let's just keep it really simple with an integer. And I think, let's just say, I don't know. No, we'll make it a float right away, because it's easier. Then I can change in how many steps, for example, I blend out later on. It's nicer if I can just start with a range from 0 to 1 and then later on decide how finely I chop that down. So let's say we have extended our field definition from just a color to a color and an opacity. So I will just save this and try to get my code to compile again. And we see like, oh, actually it's not too bad. It's not too bad at all. So it's only this function that maps all the colors here. So I think I will just for now, for those, oh, let's return a string and an opacity, because I know already I want to use this value eventually. So if it's empty, then it's just full on gray. Whoops. And for all the others, I'm lazy of typing then to type, so I just call it O here. O. Oh, record a little Vim macro, so that next time here I just have to do this. Vim macros are really nice. I don't know if you haven't worked with Vim, then it probably looks somewhat magical. That's stuff like this, but it's for, as a developer, I can only recommend for people. Or I don't know, maybe I'm also just a old guy that has problem adapting to new stuff, but I really like my Vim. All right, so field FF to colors. So now it probably will complain about the fact that this, no, it's actually somewhere else. Or is it? Line 163. Update field. No, I think it's a transient error based on the fact that we're not consuming this tuple right here. So I know for sure that I have to deconstruct grab the color value from this tuple now. So let's, I don't know, color, name, and the opacity we ignore for now. And now I messed this up. Color name. I'm not calling a function anymore, so I can remove this pipe operator. I'm still not happy. 163. Oh, actually there are multiple errors, right? I'll just clear my console and have it compile again. Oh yeah, okay, so there's some more stuff than just what I just fixed. So let's go through it one by one. 581. Color fields. What is fields? Actually, I think the problem is probably also that our tile definitions. Let's start there. Like I mean, I could follow the compiler errors here, but it's a bit tedious because basically what are expected to be values are now probably functions, because they contain fields which have their last parameter not field, the opacity parameter. So everything that was just a field before is now a function that expects an opacity as parameter and returns a field. So yeah, it's exactly, we see this here already. So it was supposed to be just a field, but we see like, okay, it's basically you can reverse read these signatures. In that case, it's now, instead of just a field, it's a field that expects still the opacity parameter. And I have a good hunch where this is coming from, because ultimately our fields are created from our piece definitions. So, and we see here color is green. Oh, piece definition. How is piece definition defined? Oh yeah, that makes sense. I don't want to put an opacity into our piece definition. That doesn't make sense. But when we generate a new piece in our actual board when we're playing, we grab the random piece definition and then we turn this into the current piece. And when we do that, I still don't want to have opacity in our current piece because that's always like fully opaque. So it's really only when we place the current piece, when we bake it into the board, that's probably when we want to generate or assign the 100% opacity to our field. So let's place piece on board function. What are we doing here? Oh, that's a long function. Whoops, I lost where I was. Color in positions. Okay. Let's go from the bottom up. Over rows, new rows. Update with piece. What is update with? Okay, so it's color in positions. Oh yeah, well, it's not so bad after all. Yeah, and here we see, well, I could have just searched for the calls on vocations of the constructor. So here I will just say, whoops, 1.0. That should at least clear up some of those. Okay, and now it's still in 163. And I already see a good contester for the culprit here. So I will also just, for now, I just fill in all the missing opacities with 1.0. And now at least it's compiling again, and I have a good feeling that also, like, if I do a refactoring like this in Elm, I have very high confidence that at the point where it's compiling again and I just added a field or something, that I didn't break anything at least. So that should still do what it's supposed to do. Let's get this row vanished. Wonderful. Okay. Yeah, nice. So that still works. So maybe what we could do, now we have to start reducing the opacity on lines that are full before we remove them from the board. So it's like on one hand, the erase rows function or whatever it was called gets a bit more complicated now, because we cannot just remove rows once they are yeah, maybe we should also introduce a like dedicated variant for a fading row, because it's, I would argue, it's the pieces or the tiles in a row never fade individually differently from each other. It's either all of them fade or none of them fades. So let's see how. So now I regret not having made this git commit, because then I could easily roll back onto this state. So, but I think I want to revisit my definition of the row type, because I feel like I already, where is it defined? Type row. Yeah, that's actually maybe that makes a lot more sense. So actually, yeah, I will revert all my changes for opacity, because I think it's unnecessarily complicated. I mean, we can keep the type alias, but I will just not add this field to the opacity parameter to this thingy, and it's compiling again. So we have successfully, I've successfully reverted that change. And what I actually want to do is I want to have a second row variant called fading row, because now I only have to store the opacity once for all fields in this row. Cool. This should be a pipe, and now stuff will break. Okay, where to start? Line 440. If is full, erase complete rows. Well, that's directly where it gets interesting. So I don't know. That will be one of the more tricky parts, definitely to adjust. So I will just do case row of row fields and fading row fields is the same. Yeah. So I'll just copy this expression for now. It will definitely not do something apart from making it compile again, but that's a good start. The fading row variant needs 2 arguments. That's correct, because now we also have an opacity here. So let's give him that. And now it's line 635. Yeah, we have another case statement pattern matching here for our row. So again, I will just copy anything that was already there. I will just do the same for the row view. So yeah, well, that will actually get interesting, because yeah, it's really, it might get actually easier with this approach than with the opacity per field, because field view for row, yeah, we'll see about this, but this will be the interesting part where we have the opportunity to actually incorporate the opacity value in our rendering and make it more transparent or whatnot. So yeah, change this, and now it's 449 next error. Let's bring this to the top. Again, we're deconstructing only for that case. Which function is this? It's again erase complete rows. So I will just be lazy and copy this whole thing again for both cases. So let's do a little case. Row of, then we can grab this from the parentheses here. Boom, add some indentation and grab the branch here and add the fading and the ignore parameter for this. So now I have some weird stuff here in the parameters. Remove all of this. Right. 433, just above. Same thing. So replace with nothing. Full. If is full, then empty row. How do I use this function? I'm not using it at all, so that's a good find. That's an easy fix for a change. Let's just throw that away. And now it's 369. Okay, we have another pattern match on the row, so let's fading row fields, ignore opacity. That's okay. Boom. 581. Like, and it's I really like it shows really how brain dead this work is. Like, I'm just really following the compiler here. I mean, I think I'm making the code worse in some places where I just copied a lot of stuff. But yeah, I try to make it work first, and then I make it pretty again. So let's change this here to row, and then we create a fields expression where we again pattern match over that row. If it's row fields, then it's fields, and if it's fading row fields, opacity, then it's also fields. Boom. What? 583 fields. Yeah. Okay, I know that I'm using the fields because that was the name that to what it was deconstructed before in the parameters, so I want to keep this if possible, so I'll just rename those others here to FS. And there's still one compile error because update row as old row. Okay, old row is good. We now just have to do the same trick where we extract the fields equals dot pattern match case old row of row fs fading row fs. Boom. Come on, you can do it. Nope, not yet. 158 because I missed the opacity here that I'm currently not interested. And we're compiling again. Well, like at some point, if it's not compiling for too long period of time, I'm getting a bit nervous. So that was kind of the maximum, at least for while being watched. So let's see if the removing row still works too. So cool. That's good. Now we could do two things. I think I want to look into the rendering first. Like I want to put a line. I want to put the opacity to 50% and just make sure it looks appropriate before I force pieces into the state, because if I know I can display it correctly, then I can just use the visual confirmation or have the if I mess up my logic, then and I don't know if it's rendered correctly, then I don't know if I messed up my logic or I messed up the rendering. So I want to make sure the rendering works first before I try to approach what I think is the more complicated stuff and fixing all the places where I have to modify the opacity. So let's see, how do we do this? Field. Because currently it's not that I have an empty board into which I place the pieces. Currently also the empty parts of the board are made up by something that looks like a piece, but it's just gray. So I think I probably want to field. I have to get down the opacity here somehow. So I guess it comes down field for row. Okay, let's see. Where's this called? Yeah, and here we see, like here it's row view is the perfect place for us to finally grab this opacity and pass it down. Yeah, I made a mistake, I think. Because I just thought we actually might have cases. Maybe I have to roll it all back all over again. Maybe like if I forgot about the current piece. So it could be that we have a row that's currently fading with one hole in the middle, and that's where the tip of the... Oh no. No, the current piece cannot tip into a fading row because a fading row has to be complete. Okay. Whew. Dodged the bullet there. So that means we can still, or I can still continue to surf on my assumption that I always have to fade a whole row. So I think I will just pass in the opacity here in our field view for row. Opacity. And that means in a row that's non-fading, I can just pass in 1.0. That should be fine. So now we have to tweak the field view for row function, which is defined directly above here. And instead of row index and then column index, it will take row index and opacity. Opacity. So we're not doing anything with it, so it should compile. Yeah, looks good. And field view. Do I want field view? I mean, I'm just contemplating how I implement this on the SVG layer. If I try to put a wrapper around all the fading pieces in a row and then fade the whole container, or if I fade the pieces individually. I think I will do the naive approach for now and just fade each field separately, because it makes for a more trivial follow-up here. I will just pop in the opacity here as well. Oh, does not spell opacity. Opacity. And opacity. Opacity. So FF to color. And there's probably an attribute in SVG attributes for opacity. Maybe I can just use this. Elm SVG opacity. Opacity. Let's see. Opacity. Fill opacity. Where isn't the opacity? Fill opacity. What's the difference? I'm not sure. Let's use fill opacity. That sounds, we have already fill, so maybe fill opacity, fill. And what does it want? What parameters does it take? Fill opacity takes a string. What is fill opacity? Okay, I have to Google this. SVG fill opacity. It's a presentation attribute defining the opacity of the paint server. Okay, but it looks like it's just a float. Ah no, it could also be a percentage. Oh, I see. Yeah, well, I think I'll go with a float for now. So that means I can just call from float with opacity. It's really not my word today. From float is not imported yet, so let's see where's from string and from int, sorry, and just add from float there. Compiled without errors, isn't that great? So well, since again we're not changing the opacity of any piece anywhere, so I don't expect to see any changes. But again, just to confirm that this makes visually sense, I think I want to just hop back where I say set the constant 1.0, because we're not ever constructing a fading row yet, so it's useless to try to fiddle with these branches. But I will just replace this constant here with 0.3. So let's see how that looks. Boom. So that definitely looks faded. I think it's fair to say that we never want to fade an empty piece. That just doesn't make sense. So that's a branch that I can address right away. So case field of empty. And again, I will just maybe. No, I said I will do another refactoring and I have to create some material for that, I guess. So I will just bluntly copy and paste some stuff here. So if we have an empty field, then we can just ignore the... Yes, I'm cringing at the duplication here, but I just removed the opacity for the empty case. Why do we have two empty cases, which doesn't make sense? So yeah, now at least our empty fields look gray again. But the thing that I really don't like is the gray, the green faded pieces, which have a 0.3 opacity now. They don't look like they're shining through to the gray of the empty board, but they are, because there's no empty board piece behind them, and that's why they are fading into the white, which is of course not correct. They should fade into gray. So I think the easiest, most naive fix for this would be to render, and maybe now it's time to actually create an extra function for this. So let's say empty field view. Okay. New function, empty field view. We do need only the positions. So two ints, int, and return an HTML message. That is okay. So here we can just say hard code the gray, or what did we use? Yeah, we used gray. So this should still, I have to actually, what do they call it? Column and row. Column and row, an equal sign on the end is also nice. Does it compile? It does not compile because I didn't pass in. Well, I have row and column in the other functions, so I should probably stick with one order. Column, jump back to line 691. Row, column. Do we compile? Yes, we do. And it looks nice again. Good. And now I think I will just, instead of only returning one rect for the rectangle for the filled pieces, I will just return 2 of them. Isn't that nasty? It's probably not the most performant. I could probably calculate the right mixture of a color that's fading from the full color to the gray, but I'm lazy. You should know that by now. So empty field view, row, column. And the problem is now, of course, like we have 2 elements that we're returning. So I have to change my return type here to an array and then concatenate this one level higher. Here it's now returning a list. And where do we call field view? We call it here. So we have to say concat of whatever. Oh no, that's actually not field view. Am I mapping here somewhere? What is this thing? I don't know. I just know that wherever I'm mapping over my fields, which is here, I have to concatenate this. Concat. Nope. I'm switching too much between German and English keyboard layout. It's killing my brain or my fingers, depending on where more typing action actually happens. Concat is not imported yet. Going to jump all the way to the top to my list import and add the concat function. And if you're not familiar with it, it's basically also what's called flatten in Ruby, for example. So if we have a list of lists, then it takes all the elements from the sublists and concatenates them into one list. So is it happy now? No, still not happy. 651. 651. Yes, that's correct. This is also returning a list of HTML now. I don't even know what this function does. Could probably collapse it. Okay, now that looks like a faded blue. That makes me happy. I also think our gray is a bit too dark for the empty board. So I think I will just go here and come up with a hex code that is not as dark. So maybe D gray. Yeah, that looks a bit better. A bit too bright, maybe. C does the job. Yeah, that's nice. I like it. Good. So now comes the actual part of starting to fade rows. So I think the natural entry point is when we have to distinguish now when I start or wonder programmatically speaking, if I should erase rows, there are 2 or 3 cases now. It's not just yes should be removed or no should not be removed. It's like, where do I start? Like if the row is full, then it should be turned into a fading row with the starting opacity. If the fading row is already present, then I should reduce the opacity, and if the opacity is below a certain threshold, then I should actually remove. So it's maybe it's actually complexity is not as bad as I thought in this. For this erase rows. I mean, erase is probably also not a good name after the change I'm going to make, but I'm not going to worry about that too much. Is full. So what do we do? We have this folding function. This very binary folding function. So is full. So if it's full, then what we have to do is turn this row. Okay, but we already have the distinction here, so that's good. So it's not binary anymore. We have now two cases for. Okay. It's not too bad. It's not too bad. It's a bit late to having to do this kind of brain gymnastics now, but it's okay. So if the row is full, then we don't do that just yet. So what we actually want to do in that case is we want to do something similar, like we're not removing it from the board and creating a new row that we are going to put on top. We are going to modify the row. We are going to turn it into a fading row. So actually it's not that hard. I just have to say fading row. I take the fields and the opacity is 1.0. It's not bad at all. So does it compile? It compiles. I have no clue what this does now when a row is full, but I'm pretty sure that like more than half of what's needed is still missing. So let's revisit our logic here. If we have a not faded row and this row is full, then we turn it into a fading row, but leave it where it is. So that sounds good. And if the row is not full, then we don't touch the row at all, which is also good. If we have a fading row, then it actually doesn't matter if it's fading or not. So we can relieve. Oh no, actually we have to have still a split, but on a different condition. We want to look at the opacity, and we want to say if the opacity is smaller or equals arbitrary value smaller than 0.1, then we do the thing. Then we take it out of our remaining rows, or the rows that we want to keep on the board, and add an empty row. Oh, this is good. I like it. I think this looks good. This looks good. So now we just have to decrease. Oh no, and if we don't want to remove the row, then we have to decrease the opacity for the... actually it pans out really well. So then we have to create a new fading row with the same fields, but opacity minus, again, arbitrary delta 0.1. Whoop whoop. Syntax error 477. Whoops. I missed a closing bracket here somewhere. Compiled without a... Oh, I'm so curious. There might actually something be working right now already. Also, I still have my 0.5 hack in there, but anyway. I'm so curious what happens now. The opacity changes. I think that can be concluded. But it's... Oh no, it's fading. Is it fading? It's fading, but not at the frequency that I was hoping for it to do so. So it's only if we place a piece that it's fading. Okay, that takes a bit too long. First I want to find my 0.5. I'm pretty oh no, 0.3 it was. 0.3. It should be 1.0, of course. So that our pieces look nice, vibrant again. Yes, that looks good. So But back to our, where was it? Erase. Boom. Bring that to the top. So when do we call erase or complete function? So this is, yeah, that's what I thought. So we only call the erase complete rows when we cannot drop the current piece, and that's wrong, obviously. Like we should even update it even more often than when the piece is dropping. I'm just reusing this rhythm right now. So actually I think I can just call this here. And then it should run either way, right? Both branches. Now it's not happy. Oh yeah, this is on the wrong side. It should be here. Now it's not dropping at all anymore. Also funny. Because it's placing erase. Okay. Too easy. Erase complete rows also places the piece on the current board. So, I don't like it. I think I'll make a separate function. I make a separate function that says progress fade. Progress fading, maybe. Takes game details, gives game details. Progress fading, I don't know, something equals, and then I will, what will I copy? I will... Well, I don't have to remove anything, so it should be just a map over the rows, right? So let's grab the board, or let's game details. Let in, and we want to update the game details, and we no, the original game details, and we want to create a new board that has the faded rows. So old board and rows is faded rows. Old board is game details dot board, and faded rows is definitely a map over the board rows. So that's old board rows. So here's a function that I haven't written yet, and then we have old board dot rows. So I don't know what's, maybe just call it fade row. Fade row is a good name because it's fading a row. Fade row or row. Case row of, if it's a not faded row, then we just return it, because non-fading rows don't fade. But the fading row with the fields and the old opacity this is going to be a new fading row with the same fields and the opacity -1, -0.1. Okay. Does that make sense? Is it complete? It's definitely weirdly named up here. Details. Oh, I think I made this typo in several places. Game details. It's only here. So that's compiling. Now we just have to use it. Progress fading. So let's put this here. Progress fading. Okay, that's not going to be the first complete row, the lowest one. Let's aim for the second one. Why are you not fading? Damn it. Huh. Did I miss something? Okay, I know I'm confused. Let's try to reconstruct this. It started to fade. Weird. That row will not be complete anytime soon. So let's go for the second one again. Okay, so when does it start to fade? Oh no, it looks... I mean, it fades a bit too slow, that's for sure. But it... maybe the first 30% of the fade are just... it's not so linear as I was expecting. Come on, give me the right LPs. It's really starting to feel like a real Tetris. It's the wrong one, I need the blue one. Or actually I can also just use this one. Oh yeah, no, I think it's fine. So now we want this to fade, obviously. We want this to fade a lot faster. So we have to decrease our timer again, but then we don't necessarily want our pieces to drop also faster. So the way I would go about this is probably I would just like only drop the piece a piece every, like increase the frequency of the callback that the timer hits our logic there, increases by 10, but then only drop a piece every 10th tick, so to say. The question is, how do we know how much? Like, I think we have to introduce a counter for how often the timer has triggered. So let's see. I would go to my subscriptions and see like, okay, tick every 300 milliseconds. So let's just for the fun of it decrease this to a 10th. So I'm sure the fading animation looks great now. It's just that that I will not be able to produce a full line at that speed. So gravity tick, what happens? Gravity tick is also not a good name anymore, kind of, because it's not just about gravity anymore. But again, I'll keep this for the refactoring session maybe next week. No, actually next week I won't be able to stream because I will be on the road to Toronto. Yeah, I don't know. Maybe I managed to come up with something a bit ahead of time, or no, or after the fact. I don't know. And maybe I'll just put up a blog post or something. I'll see what I can do. Anyway, gravity tick. I wanted to increase the tick. Running game, yeah. So I think I will just extend my game details with another member tick. This will be an int. And let's go back to, now we have to, of course, when we initialize our game details, we want to initialize this as well. Tick is 0. Yeah, tick is 0, and now every time we get gravity tick, we will just say, oh yeah, actually drop current piece. So this is good. This makes sense. So basically now we can say, instead of dropping the current piece at every tick, we only want to drop it at every 10th tick. So I would say if, whoops, game details dot tick mod, I believe mod by 10 is the modulo operator. If this is 0, then we actually drop the piece, and otherwise we return when we still have to in any case we have to return the increase the tick number, otherwise we will never drop. So I'll just craft something locally here. Oops. This should eventually be moved out into its own function, so it doesn't live in the update function, but I just want to get it working again. So next, game details, details. Oh, I wrote it with an uppercase D, so I'm going to stick with this. Is like if it's a 10th tick, then we drop the current piece. Otherwise, we leave this unaltered. In fix indentation here, yeah, looks good. We have to create a tuple of our model and a command. I already know I don't want to have any commands here, I guess, or do I? Oh yeah, I guess drop current piece. Okay, no, I'm not going to do this here. Just increase tick game details. So drop current piece is probably a function that returns the whole shebang, model and command. So we can just copy the signature and say just increase tick. Takes game details, and returns the same game details, but with tick equals game details dot tick plus 1. Boom. And of course we also have to increase the tick if we drop the current piece. So I don't know if there's a a simple way to do this. Or maybe we say just increase tick creates. Or maybe we actually call it just increase tick, like literally remove the just. Change find uppercase I, increase tick. So now we can chain it into here basically, which I find nice. So let's say increase tick, boom, is here. And in the else branch, we also want to increase tick. And now I still have to just increase tick, and I have to construct my proper tuple here. Command none, not too hard. Okay, a long time hacking without compilation. That, as I said, it always makes me a bit uneasy. If game details 251, maybe I have to give it some parentheses here. Mod by 10. I think this is the way to write it. I'm looking for one of the following things. More letters in the definition. Why is it not happy? Because I have this dangling let here. 4 to 1. Why is it not happy here? Because I am missing this here. And now it's compiling. Okay, cool. So the speed, noteworthy speed of at which the tiles drop looks a bit more human friendly again. And now I'm curious if our fading actually works at the expected speed. That looks still pretty slow. Why is that? Because, okay, what did I call it? Fade row stuff is still happening as part of the drop current piece. So that's not no bueno. Let's move this out of here. It's a function from game details to game details. So those are the most composable function, I would say, in our little Tetris here. So I just can, instead of only doing it when we're calling drop current piece, we're calling it every time now. So I forgot how I called it. Progress fading, fade rows, progress fading. So here we say increase tick is correct, but also progress fading. Now we can also use this to break at these little arrows. And drop current piece. I mean, we still want to fade when we drop the current piece, I guess. But then again, I also think it doesn't make such a big difference. So watch me puzzle, hopefully for the last time tonight, to get to the desired result of having decent dropping speed with fast fading full rows. I have a good feeling about this. Boom! The row is a bit long there for my taste. Yeah. Because no, yeah, no, that's okay.
One eternity later.
I have the feeling it's something super obvious that I'm missing.
3:28 a.m.
Ugh, boy. Yeah, I think I will call it a day. I think you have to know when it's time to take a break. And for me, that's it now. The 2 hours, I think my brain is just melted. Yeah, as I said, next week I won't be able to stream, but I think I will at least take a minute before in 2 weeks and try to hunt down whatever weirdness I've constructed here today. So, if you stayed with me that long, thanks for your patience and see you next time.